This video is going to help you get through the portion in your packet that's titled Time to Hit the Slopes. This section is all about finding the slope of a line when you have different information about the line. So at first, we're going to suppose that we have a table of values that has some of the points on the line. So here's an example of a table of values, and we have 3 points on the line, 0, 2, 1, 3, and 2, 4. If we wanted to, we could graph this line 0, 2, 1, 3, 2, 4, and then we could connect those. And the question that we're trying to answer is, what is the slope of that line? What is the slope of the line that goes through those 3 points? If we remember that the slope of a line is the rise over run, we need to calculate the rise and the run using these points. So what we'll do is we'll start off, let's look at the rise first. Remember, the y-axis is the axis that goes up and down. So when you change a point's y-coordinate, you move that point up or down. To find the rise of this line, we're going to look at the y side of our table. When we go from a y value of 2 to a y value of 3, we're going up by 1. So here, this point here has a y-coordinate of 2. This point here has a y-coordinate of 3. And we went up by 1 to get from one point to the other. That means that the rise of our line is positive 1. We're going up 1. Now if we switch over to the other side and we look at the x-coordinates, as we go from an x value of 0 to an x value of 1, we're going, again, the number is increasing or going up by 1. So in this point to this point, we go from an x value of 0 over to an x value of 1. So in this case, our run is positive 1. And then we need to remember that our slope is rise over run. The rise is positive 1. We have that from here. And the run is also positive 1 from here. Positive 1 over positive 1. Well, a positive divided by a positive still gives us a positive, and 1 over 1 is just 1. So the slope of this line is 1. Next, we'll look at what happens in a case where the x value doesn't go up by 1 at each time. What if it goes up by some bigger number? So let's look at this next example here. The y values go from 5 to negative 1 in this step. That's going down a whole bunch. We're going from 5 all the way down to 0 and then even down some more to get to negative 1. This is going down by a total of 6 steps. On the other side, if we look at x for the same 2 points, we go from 2 down to 0. Again, on this side, we're going down by 2. So our run in this case is negative 2, and our rise is negative 6. So our rise over run is negative 6 over negative 2. A negative over a negative gives us a positive, and 6 over 2 is 3. So the slope of this line is 3. I'm going to let you do the next problem on your own, and I'll give you a brief hint to help you with the remaining 3 problems. In this case, I gave you 3 points listed as xy coordinates. You can easily take those coordinates and put them into a table if you'd like. So in this case, the x value is 1 and the y value is 4. And we can put the other points into the table if we would like. Now notice that we don't have to. We could directly find the rise and the run from looking at the points themselves, but it might help you if you put them into a table. Please pause this video while you finish the problems on this page. When this video resumes, we'll be looking at the next page. Next, we're going to look at how do we find the slope of a line if we have the line on a graph. So here's an example of a line, and I'd like to know what the slope is, what the rise over run is. The first thing that I'm going to do is I'm going to pick any 2 points on that line. It doesn't matter which 2 points I pick. So I'm going to pick those 2 points. My job will be easiest if I pick points that fall directly at the intersection of 2 of the lines on the coordinate plane. And then I'm going to think to myself, slope is rise over run. So I need to imagine, like a little ant who can only crawl along the grid lines, how does he get from one point to the other? Let's say that he starts at this point down below. The first thing he has to do is go up 2 steps. 1, 2. He's going up 2 steps. So my rise in this case is positive 2. Then he has to turn and go over another 2 steps. So my run in this case is positive 2. How do I know that the run is positive? Well, if you think of the x-axis as just being a number line, this is where you'd find the positive numbers, and this is where you'd find the negative numbers. And the ant was crawling towards the positive direction to get to the second point. So in this case, 2 over 2 is 1. Now, a reasonable question that you might ask in a case like this is, does it matter which 2 points you pick and which direction you go between them? And the answer is no, it doesn't. Let me show you an example to illustrate that. I'm going to pick 2 different points on the line, and this time I'm going to start at the point that's higher up on the line, and I'm going to work my way down to the point that's lower on the line. So in this case, rise, over, run. And it also doesn't matter whether I start with the run or I start with the rise. So let's start with the run this time. Imagine I start at this higher point, and I'm going to go to get to this lower point. The first thing I do is I go backwards 3 steps. 1, 2, 3 steps, and I'm heading in the negative direction on the x-axis, so my run in this case is negative 3. Then I'm going to go down 3 steps to get to this point. 1, 2, 3 points down. So my rise is negative. I'm going down on the y-axis. This is the negative direction on the y-axis, negative 3. Notice that negative 3 over negative 3 still simplifies to 1. It's the same answer that I got for a slope when I used 2 different points. And this is important. Slope is a measure of steepness of the line, and the line isn't any steeper in one part than another. So no matter which part of the line I look at, the little part between these 2 blue points, or between these 2 orange points, or anywhere else, I should get the same slope every time. Please pause this while you finish the rest of the questions on this page. On this next page, the problems continue to ask you to find the slope of a line when you're given the graph. There's one of these that you might need a little bit of help on. If you come down to number 5 here, you see that we have a line that goes straight up and down here. Let's use what we know about slope to do some calculations on this. We need to find rise over run. Let's pick 2 points on the line. Any 2 points will do. I'm going to pick this point here and this point here. So I think about going from one point to the other. My rise, I go up 2, so my rise is plus 2. My run, though, when I'm going left to right on this one, I don't move at all. I don't move left and I don't move right. So my run in this case is 0. 2 divided by 0. If you enter that in your calculator, it's going to give you a message that says error. We are not allowed to divide by 0. That operation in math is undefined. So we would say that the slope of this line is undefined. Go ahead and finish up the problems on this page if you haven't already done so. When you restart, we'll pick up on the next page. On this page, the next thing that we need to do is we need to either take these 2 points and graph them and then use rise over run to find our slope, or we need to take these 2 points and put them in a table. Since the directions say to graph the following ordered pairs, let's use that graph to find the slope. So the first point is 1, negative 2. So I go over 1 on the x-axis and down 2 on the y-axis. That's my first point. Next, I have negative 3, 4. So I go backwards 3, 1, 2, 3 on the x-axis, and up 4 on the y-axis. 1, 2, 3, 4. So now I have these 2 points, and we know that I can draw a straight line through any 2 points. And so I'd like to find what is the slope of the line that goes through those 2 points. Well, I need to know rise, and I need to know run. So I'm going to start at one of the points and work my way along the grid lines to the other point. I need to go up 1, 2, 3, 4, 5, 6. So my rise is going up 6. And then the run in this case is backwards. 1, 2, 3, 4. I'm going to the left or to the negative direction in the x-axis. So I'm going back 4. So my rise over run is positive 6 over negative 4. Remember, a positive divided by a negative is a negative. We're going to leave our answer in fraction form, but we are going to simplify this fraction. 6/4 is equivalent to 3/2. If I divide the numerator by 2 and then divide the denominator by 2, I get this equivalent fraction. So the slope here is -3/2. The reason it's useful to leave our slopes in fraction form, even improper fraction form, is we can clearly see when we look at a slope in fraction form what the rise is and what the run is. If I had turned this into a decimal, I would have lost that ability to see the rise and the run. This is the end of the notes that go with your packet on slope. If you haven't already done so, now is a good time to watch the Slope Dude video that's linked in Moodle. That'll help you with the beginning homework on the next page.